Hello everyone, my name is Mr. Hartz and I teach a robotics course here at Los Osos High School. It's a D-level science course, so basically it is a lab science. This counts for college credit just as much as any chemistry, physics, biology course would be counting towards it. And basically we just build and design and program robots throughout the entire year. So I basically probably enjoy this course teaching it more than any other one out there because it's just playing with toys quite a bit. So let me just give you a quick little idea of what you're looking at for this course, and hopefully you'll be interested in signing up for it with your counselor. So we start off with CAD design, so we'll be teaching you how to draw what we call isometric or 3D pictures. We'll teach you the rules of CAD design and such, and it'll be all drawn by hand to start off with, just some basic rules and walking you through it. That will lead us up to working with actual real 3D models. We like to use Legos to kind of begin building a lot of these things, but what you'll do is you'll build it and then you'll take that built model and go into what we call Onshape. It's a CAD design program that you guys will learn where you'll be able to create 3D models inside of space that after we are done, we will take these 3D models and 3D print them. We've got actually at least 4 3D printers in this room running quite often, and this actual project you'll be able to keep your final product. But it's just kind of getting them used to actually working with the 3D modeling and also our 3D printers. Another thing we can do in Onshape is actually design three-dimensional models that actually will work and spin and rotate. We call these assemblies. So we'll spend quite a bit of time teaching you guys how to CAD design. It's definitely an important skill that you'll be able to use possibly in your career later on. 3D printers, we've actually upgraded these ones to a little bit higher, nicer ones. But again, a 3D printer is just nothing more than a model making machine that can put out within an hour a product that you created online. So you'll be actually creating material that didn't exist in the first place. We will also teach you how to program. We'll usually begin programming in Scratch just to kind of give you an idea of how to program in the first place. I'm assuming that nobody's coming in with any kind of programming language experience, so don't worry about anything like that. And we'll be starting off probably designing games and doing different things where the kids will enjoy actually doing some simple programming before we get into what we'll be doing kind of moving forward. And then we move into actually working with our circuits. So we'll be talking about series and parallel circuits. We start off working with these little LED bulbs. We'll be working with switches and buttons and knobs and motors and a lot of different sensors and things that will connect up to what we call an Arduino. That's a little blue guy that you see there. He's going to be our computer, basically programming all the little parts to do whatever we tell them to do. So we'll be designing all different circuits throughout the entire year. One of the first circuits we actually will be building towards Christmas time there is a holiday tree, and one of the things you'll learn at that point is how to solder. So it's another skill. It's pretty useful moving forward, especially if you're going to be working in circuitry whatsoever. So this little holiday tree will be our first actual major project that we'll be doing as a team. We'll actually have you guys design your own tree. You will be 3D printing the tree. We'll be using the soldered little LEDs to plug into it. And then on top we'll have an RGB bulb, which will change all different colors. And we have a little tiny speaker there. And it'll be playing whatever songs you guys program it to do. We'll be moving on to then working with ultrasonic sensors that measure distances from one another. That'll lead us into our parking lot project, where you'll design a working parking lot with gates and lights and such to basically move a car through it. And then again, this will be another major project that we'll do with teams. Then we'll move into designing our own maze. So the actual top of that maze, every student will design their own, and we'll control the maze using a couple gimbals. And we'll do it with a keypad. We'll have a joystick. We'll be using, again, knobs. And then we actually did a Jedi mind trick one this year where we were controlling it just with our hands alone. We move on to our drawbots. These drawbots will do a variety of different things. Well, first and foremost, they draw. So we will actually have them drawing pictures, and we'll have them drawing letters and different things. They'll just move along a piece of paper, dragging a pen behind them, lifting the pen up and down whenever they need to, and drawing whatever you program to do it. You'll build these bots from scratch. You'll wire it up. Every single student will have their own drawbot, and we'll spend several weeks doing multiple different projects working with these little guys. We'll even have it drawing a house at some point. Then we move into having to do a little follow bot where they'll basically keep track of a distance in front of another one, and that front guy will just stop and move forward and backwards whenever he wants. And again, your job is to just keep the distance at all times using ultrasonic sensors. These are kind of sensors you see on Teslas and a lot of other cars. Then we'll move into possibly maybe doing a spider bot. Haven't done that for a while though, but again, we got a variety of different projects we can use. Also with the draw bot, we'll make a maze bot out of it, where you'll have it try to navigate through a maze without running into any walls and try to get out of the maze as fast as possible. These are not going to be controlled by students. They're all autonomous. And then we move into what we call a line bot. This will be the actual first project that the students will create completely and utterly from scratch. You'll first prototype it with cardboard and then actually design all the parts in CAD, and then you'll basically build the parts and program them to follow a black line around the room as fast as possible. Again, another team project. This one will take a couple weeks to go and completely get done from scratch. And your job is to just basically simply beat my line bot that I built a long time ago. So that's another major project that we use. We made a little tiny racetrack out of it at one point. Have a little drag race. Give out some trophies here and there to the winning teams, of course. Got to celebrate. We've done catapults. We've done hydrofoils as well a little bit, kind of tinkering with those kind of ideas. This year, we are actually going to be possibly doing a district competition with little tiny ant bots, we call them, where they're about 150 grams, and we'll 3D print all the parts and create a weapon and basically put them into an octagon and have them compete against one another. So that's our new project that possibly might happen this year. This was actual sumo bot or competition bot I was just tinkering with a couple years back that will search and seek out. We'll use ours. We'll actually control ours with a remote control. This one was completely autonomous. And yeah, it's just a really fun course, something that you'll be able to take with you into whatever discipline you're moving into. You'll learn programming, you'll learn CAD design, you'll learn how to work with electronics. And again, it's just playing with toys all year long. So hope to possibly see you next year, and just speak with your counselors if this is a course that you'll be interested in taking. Robotics 1 with Mr. Hartz. All right, thanks for listening. Bye-bye.